Hello, and welcome to today's Saratech enablement session. My name is Andrea Hall, and I am the Customer Relationship Manager here at Saratech, and I'll be your host today. Presenting today, we have Mark Anderson, and he'll be talking to you about multi-axis feature-based programming and feature recognition in NX CAM. Our sessions run about 30 minutes each. They are all recorded and posted to our Saratech YouTube channel. Make sure you check out our past sessions there. Twice a month, we meet right here to learn about tips, tricks, new and old features that'll help you in your everyday tasks. This is an open forum, so if you have questions or comments during the presentation, please type them into the question box on the right-hand side, and I will kindly interrupt Mark and let him know about your comments or questions. And with that, I am going to pass it over to Mark.
Hello, my name is Mark Anderson. As Andrea said, I'm an application engineer for Saratech, and I specialize in the CAM products, NX CAM. And today we're going to be talking about the feature-based recognition. And today we're going to focus on mill-turn machines because they're the most difficult machine for any CAM system in the world to pick up features and program them automatically. But today I'm going to show you how simple it is with NX and how powerful it is. So here's our agenda. We're going to explore the different section possibilities within feature-based manufacturing, the power within NX to find not only smart features, and what I refer to as smart features are when you bring in a model that has a feature tree of how it was built, NX goes right to that feature tree and it pulls those features out. So if they modeled it with, say, there's a tapped hole and they use the tapped hole command in the modeling side, then it'll pull that right out of there. But what it also does is it pulls CAD data from dumb models that has no feature tree, and it selects machinable features. Machinable features, by definition, are any 2.5 axis or below feature that has a flat surface. It will not do curvatures like 3D machining, but it will do any 2.5 axis feature, holes, anything like that, in any axis as well. So I'm also going to show you how feature-based manufacturing handles mill-turn parts with a B-axis upper head. That's what we're going to be specializing in today, or specifying today, because 90% of all your other CAM systems, they will not do that because it just cannot understand the normal direction of the axis it needs to do to machine that feature. And then what I'm going to heavily talk about today is grouping features and then the group view of the navigator. And with that, if just say you had a tapped hole, there's 3 different features: a chamfer, a cylinder, and then the tap. So if you program that manually, you would have to select drilling or hole machining for your center drill and select the hole. Drill, select the hole. Tap, select the hole. So by grouping your features together in the operation, in the dropdown, you don't have to leave it at work piece. You can actually use that feature group and it already selects those holes that you grouped together. So by saying this, you can understand that if you have a die shoe or something like that that has millions of holes in it, by just taking the time to group the features from the beginning, you save a lot of time. But by using feature-based manufacturing and feature-based recognition, it will group all those features together for you in a very, very short period of time. We're going to do a live demo on this part here, and you can see there's tons of holes on it, and it's in a B-axis lathe, so that's the orientation. I'm going to perform the feature-based manufacturing on this mill-turn part. That lends itself to B-axis upper head mill-turn to be the most efficient way to program it. I'll use a standard mill-turn template out of NX, and then we're going to customize it for our applications. We're not going to customize the template. We're going to customize the operations and the tooling to our needs. We're going to use out-of-the-box machining knowledge editor. The database behind the feature-based recognition and the feature-based manufacturing is called the machining knowledge database. And what that does is it looks at the feature, and then we've predefined with if-and statements, things like that, that if it's within this size range or this size range, use this operation, and then go one step further, go to the tooling library, which is also out of the box, and pull the correct tools that will make that feature. And I'll perform steps to interrogate the part for the smart features, and then it's going to go out and it's going to use the machinable features. And it can be anything from a hole diameter to 2.5D surface, and then the MKE, the machining knowledge editor and database, will create the operations that are compatible for that feature. Then it will assign tooling to be able to machine the feature. Once all that's done, then the operation and the tooling will populate into the different views of the Operation Navigator, and then you just generate the operation at that point. And then any modifications that can be done, you can insert anywhere in the tree of operations. So say it pulls, if you have a very, very large tool or large hole, say if you have a 60 millimeter hole, it'll pull some large diameter chamfer cutter that you may not have at your shop. You can easily just change that diameter. You might possibly have to change the operation to a circle machining or a hole machining operation, so it's not doing a drilling operation, but it happens very quickly. And you'll see that with these modifications, 99% of your program is ready. So then you can do that in 3 to 5 minutes. And then if you have to do any type of modification, you're so far ahead of if doing it manually that it's no big deal, no problem.
We did have a couple of people, Mark, sorry, we had a couple of people join late. I just wanted to let everyone know again, if you have questions or comments during the session, you can type them into the questions box on the right-hand side and Mark can answer your questions. Thank you.
All right, thank you, Andrea. So you see I have that part. The orientation is flat down, so it would be like this, which is still correct for a mill turn machine. I have my workpiece set. You must always do this for feature-based recognition in manufacturing because it has to know what your part is, and then it has to know your blanks so that it can know how to create the operation and how much material is taking off. So it's doing roughing or just finishing, things like that. So first thing I'm going to do is I'm just going to go here to our machining feature navigator, and then it has our top level part. Same thing, top level part. All I'm going to do is right click in the background, find features. You see down at the bottom, oh, I'm sorry, now it's bringing up the find feature. So we have a couple different drop downs. We have feature identification, we have legacy hole recognition, legacy face and pocket recognition, and manual recognition. And what we can do with this also is if it doesn't see a feature because it's an odd feature, we can teach that feature directly in this dialog. And then the MKE will write that into the database, and then we can find it automatically from then on. So for this demonstration, we're just going to use parametric recognition. The search method is I've designated workpiece, so it's going to do the entire workpiece. And then here, features to recognize. These are grayed out, but they're still being recognized. But these are all the different things that it will find: bosses, corner notches, grooves, holes, pockets, side notches, slots, steps, surfaces. I unselected turning because I didn't want it to do any turning operations, because it will, and EDM features. Now, machining axis direction. Generally, when you're doing a 2.5 axis part or a 3 axis part, you would select a machining axis direction of the direction of your tooling. But if I did that on a mill turn part with a B axis, then it doesn't understand how to go around the part because this is a C axis here. So what I'm going to do is I'm going to select none. I can specify a vector. I can do away from point, toward point, away from axis, or toward axis. And some of these lower selections here, specifying a vector, that's selecting a singular vector. Now, if I were to put a point in the center of this part and tell it away from that point or toward that point, then it would rotate around the part. But for this demonstration, I didn't want to do any extra geometry. I wanted to make it as simple as possible. So I'm just going to select none. Now, if you had, say you had multiple features on a part, say like you were doing a die shoe. I'm come from a stamping world, so I use die shoes a lot. There's many different features on that part, many different pockets where inserts go in and things like that. So say half the die shoe had already been done and I only wanted to do a certain amount of the die shoe. I could certainly limit that area to only work on the area that I wanted it to. Now, we have feature settings here. I can assign a color attribute to all the features so that I can use that for programming down the road, or I can add modeling features and attributes to this recognition. This dialog down here is the recognized features that it has. And all I'm going to do is I'm just going to hit find features. You can see down at the bottom it says recognizing features. This is going through the process. And I apologize up front. I live close to train tracks, and you might hear a train beeping, so I apologize up front. So it's recognizing the features. It's calling them step 4 hole, step 3 pocket. And generally what that means is if there's 2 levels to it, like a counter bore, that would be a step 2 feature. So that's all it's doing. And you can see it's picking up a ton of features. It's going all the way around this part, and it's not only picking up the holes, but it's going to pick up milling features all along this part, because there's a lot of 2.5 axis work. There is no, other than some of the angles maybe or some of the radiuses, it'll pull a ball end mill to do those and call them 2.5 axis features. You see that how in the red areas here, that's what it's selected and found. It would machine all of those features automatically. So in I say 5 clicks, I've found all my features. And if I wasn't doing this as an educational thing and I was actually programming this part, that would have only took me 30 seconds to do. And imagine if you program this manually, could you select those holes in 30 seconds to program them? You would have a large amount of time involved in just selecting and reaching out and selecting the holes. So we all are absolutely perfect at our jobs, right? No, we're not. So we could err at times. We could pick the wrong hole. We could pick the wrong feature of the hole. So there's a lot of benefit to doing this, even if you're doing a complex part. When I do contract programming for Saratech, the company I work for, I don't care if it's a 5-axis part, if it's a mill turn part on a gantry machine, whatever it may be, I always start out with feature-based manufacturing just because it gives me 90% of my program. I may have to manually program certain features, the 3D features, but all of my whole features, my 2.5D features now have a feature. And then later I can do a feature group so that I can use that in the dialog of the operation to be able to program. I don't ever have to reach back out on the program and select those features. Once I hit OK, it's going to populate this feature navigator. So you see it's found all of the axis direction normal for the holes. All of those features now have a normal axis to be able to go into and do. So now what I'm going to do while all of these are highlighted, I'm going to right click and I'm going to group feature. So this dialog, to explain it, it says the method specify. So I can select all features, below or specify. I'm going to select all features. When I select all features, it selected the features that I have here, but I'm going to do specify so that NX says, okay, I'm going to go ahead and pick all the features over that's highlighted in my left category of the feature navigator, and then I'm going to apply those to these feature types. And these would be grouped features. I still have machining axis direction as none so that it doesn't eliminate or exclude any feature. And I can group by different attributes, predefined, all, or none. I'm going to do predefined because the predefined is saying what NX has predefined as the feature. I can check machining axis direction if I'd like to, but if I did that, then some of the features would be eliminated or omitted because of the axis of the B axis there. Location, this is in the geometry view of the Operation Navigator. So we want it to be automatic. We could select anything we wanted because that's already been built. Automatically, it's going to select the work piece because that's my lowest level, the child of my MCS. So once I hit create groups, it's going to create these groups. Then when I hit OK here, in the Operation Navigator, in this menu here, you see I have feature view or group view. If I leave it at feature view, then I'm just going to be able to see these features. If I put it in group view, once I walk out, now I have my MCS mill and I have my workpiece and then I have all these feature groups. So just for an effort of time alone, I'm going to go back to a pre-programmed part. So I have the same thing. I have my features, my feature groups, and all of my features that are in here. Now, if I go back to my feature view, all I'm going to see are the features themselves. I'm not going to be able to see all of the feature groups. So once we create feature groups, we want to put it in group view so that we can see the top level. What feature group do they fall into? You see there's a ton of features here, tons and tons of features, but they're all controlled by the top level feature group. So you see when I select the feature group, all of the holes in that group highlight. I select this feature group, all of those holes highlight. So what I'm doing is I'm building a timeline of, okay, I selected the features. Now I have the groups. Now what is the benefit of using features or grouped features? Grouped features select all of those features. I don't ever have to select individual features. So that's the benefit of grouping the features. Now when I go into my Operation Navigator, you have your feature groups, and I don't see the actual features tree themselves. So it really clears up things as we're programming to just go to the group view. Now if I go to the feature view, it does not change. In Operation Navigator, you'll always be in feature group view. But in the Machining Feature Navigator, you can switch between the two groups. So what I didn't do in the previous part here is I didn't generate those operations for you so that you could see time. But what I'm going to do now is I am going to generate those features to show you that all of those holes that I've selected, I did eliminate the milling. I'm just doing the holes, but that's a lot of holes, and it generated that fast. So now what I'm going to do is show you a verification of this. I'll do a 3D dynamic. And what I did is I just created I took my part, I made a wave geometry link of it, copied it, turned my original off, and then I just used the synchronous modeling technology here in the ribbon here, and I just used delete hole, and I deleted the holes, and now I have my stock model. So as we look at how this generates and does the verification, I'm sorry, I turned it off. Play. You'll see that it has the normal axis that it needs to generate those holes. All of the holes are grouped together. It's doing them in sequence that I have it in my program order view. And it will post-process, as you know, out of the program order view. And for those who don't know, I'm sure there are some that may be new at this. I'll show you when I'm finished. You can, as you program in NX, some people like different views to program out of. Me personally, I teach this method as what to the students, and I also program this way myself. I always program out of the geometry view so that I can see my MCSs, my workpiece, and then my feature groups and my tooling. I only go into the tooling, the machining tool navigator to either put a simulation kit in or to see what turn it falls in or tooling needs. The program order view, this will program as you're programming in geometry view, the exact same chronological order. But you can change this. So if I had, all of these were different when I started. They were spot drill, drill, just like they are in the geometry view, spot drill, drill, bore, spot drill, drill, bore. Well, I didn't want that to spot drill to pull out and change tools 4 or 5 different times. So in my program order view, I just created new program folders that I called it spot drill. All my spot drills go in. I called it drill. All my drills go in. My bore, my boring goes in. Countersink, my countersink goes in, so that my program flows efficiently. And when you post process, NX always post processes out of this program order view. So sometimes when you go and you start moving things around to be the most efficient, your toolpath will go out of date. And the reason why that is because your program the IPW in process workpiece is dependent on the flow of how you programmed it in the geometry view. So if you start organizing things and you put a spot drill that was down below in a different feature group up here, your drills may go out of date because it says, hold on, what's the IPW of the process that you have now created? So then you may have to regenerate once you organize in the program order view. So I'll leave it here and then we'll go into verify again. And I want to show you the verification again because there's many different options in here. And I use verification or visualization, I'm sorry, for in-process programming. There is one very nice feature. There's many nice features, but there's one very, very nice feature that I see it underutilized in the field. Once I play this again, we're going to let it play and let it do everything. You can see my stock model is up. My original model is hidden. So the feature that I'm about to show you, it's called thickness by color. And what thickness by color does is it allows you to see what has been done, what hasn't been done, and how much material is left in areas that need more work done to it. So if you've got a large program that you're working on, it's very easy for us to get tunnel vision and forget a hole or forget that I have to step down my end mills to get corner radii, things like that. So now I can hit this analyze here. And what it's going to do is it's going to look original part, stock model, and it's going to compare the two. And then it's going to give me a color generated thickness by color. And there's graduations to it so that you can see how much material is left. But not only can you see how much material is left, but you can click on the model and it will bring up a small flash dialog next to it, and it'll say exactly how much material is left on there. Since there's a ton of holes here, it's going to take 1 second to do, but you can see the benefit of this. So anytime during programming, as I program, I look at verification often. I program an operation, I verify, program an operation, verify, program a few operations, verify. So at any time you can use this operation, this feature, to be able to see, okay, well, I forgot that, or I forgot this, or I forgot that. And it's underneath the Analyze tab in NX12. So you see it's built a model now. It's given me the graduations. I can specify a point, but you can see that this green 5 column or the 6 column is that off green color. We have a larger graduation over here on the right-hand side just for visualization. But if I wanted to at any time, I can say, okay, did I actually do the chamfer? There's 1,000th. So that means that my chamfer tool compared to the angle of the chamfer itself is off by 1,000, 13 tenths. And you can reset these colors as well, and you can make number of ranges. The highest you can go is 8, but you can drop it down to anything you want. Then you can also assign max limits and divisions. So if you want a minimum and maximum limit for it to show, so if you say that certain areas of this part have 30 thousandths on it for stock, that's going to be ground off, you can change this max and min limit to where it won't recognize that so that it can generate faster. So this is a very, very useful tool. And now if I hit apply here, it's going to lock in those colors for a different view. So I'm just going to hit OK. It's going to go back to normal. So when I hit OK here, so you can see the benefit of using feature-based manufacturing. I did this on a mill turn part with the B-axis head because most all of the other softwares out there without extensive work done to their databases cannot do this. Even out of the box programs that have the name feature in their system name. I'm not trying to bash any other systems in this CSE, so I'm not going to say names, but even the most sophisticated softwares out there that claim to have this feature-based manufacturing, they do, but they give you either remedial or blank databases that you have to build. So that's extensive work. And if you have to build the logic behind it to be able to use a B-axis head or some mill turn machine with a Y-axis or something like that, that's extensive knowledge that you have to be able to do it. With NX, it comes out of the box. I have done absolutely zero to the knowledge editor, the databases, the tooling library, or the tooling database. Nothing at all, period. So now what we're going to do is we're going to look at operations. It's selected these tools. It's built these tools for me. They came directly out of the database. So as I was saying, say it's a tool that you don't have in your operation, your tool crib, I'm sorry. All we have to do is we have to go in here. We can either edit it or we can create a new tool. The operation will go out of date, and then we just have to regenerate it. So for the sake of this demonstration, I'm going to look at first the tool. So let's go with Countersink. This Countersink, and we have a generated tool here that we can roll around, flip around, look at to make sure we have depth, distance, or anything like that. The diameter is 375/3/8. The included angle is 100. So it's not going to be correct, but I'm just going to change this value to show you how easily it is to modify. So now you see my Countersink has went out of date, and I just regenerate. So if it gives you an odd tool that you don't have in your database, just change it. If it falls outside the realm of what that tool is capable of, you just create a new operation. But instead, so say I needed to change a hole that was using a hole machining operation, a drilling operation to do a Countersink, and I needed to do a whole chamfer milling. The program is what I would pick. I would actually create a new folder for it to be in. So we'll pick none here. We'll pick NC program actually. Tool, I'm going to use just a tool. Now right here is the most important. I just have to pick which one I have to do. I don't have to go back out to the part and say this one, that one. I just pick this feature group or any of these features, and it'll automatically select all of them that you've put in that feature group. And then you just okay it. Now if you look here, it's already selected it because I have this feature group. You can just select any of the feature groups, and then you just generate. It's just that simple. So I hope what you've gathered out of this demonstration is the necessity of feature-based recognition and grouping features. Because even if your work doesn't have mill-turn parts, say you only do 2.5 axis features and you only have a CAM foundation and a 2.5 axis license, you have this technology in your seat already. So it's underutilized because it seems complex, and hopefully I've simplified it so that you have the confidence to go out and try to use it. So the rule of thumb with NX is if you have to select a feature more than one time, it is beneficial to create a feature and group that feature so that you can have the drop down inside of every operation. So you never have to reach the part again. You go out and select those 2 holes one time, or that 1 hole one time, and now you have a drop down inside of your operation every time you create an operation for those holes to be auto selected. And the benefits are exponentially grown when you have multiple features that are the same type throughout a part. Group them together automatically through feature recognition and feature-based manufacturing. So what I would like to see happen after this demonstration is that all of you go out there, just pick a previous part that you've already programmed that has a lot of 2.5 axis features, and then do this feature recognition on it. Do the group features, and then generate the operation, and see what you get out of that, and then remember how much time you had in programming it before. You will immediately see the benefit of feature-based manufacturing and feature-based recognition, and it will become your go-to. And that's my goal for this, is that feature-based manufacturing and feature-based recognition, it becomes your immediate go-to for all programming. So 5 takeaways from today's session is the speed and efficiencies of using feature-based manufacturing to start and or complete all your programs from the very beginning. Using feature-based manufacturing on even the most complex parts, including mill-turn machines with many different configurations. This will work for multi-channel machines, a B-axis upper, a turret lower, a main spindle with a C-axis, a lower turret with a Y-axis, a secondary spindle that has a C-axis. It will work for all machines because what is NX doing? It's finding machinable features or smart features in the feature tree, grouping them together, and even if NX doesn't generate the operation, you still have those features and those feature groups to very, very quickly program it manually. Using feature-based manufacturing to obtain your feature groups, and that step is feature recognition, find features, find features, group features, create operations, generate operations. 4 steps. And just as a example, this part, I counted every click that I had to do to get the program and the time that I did without this educational talk. It took 11 clicks to program that part, and it only took me 17 minutes to program. Can you imagine how long that would take us if we manually programmed it the way we always have done it, or any other CAM system in the world does? And I know those CAM systems in and out. I've been in the field for 25 years. I know what softwares will and will not do. And NX is an animal all on its own. It is the best software on the market. It is the most powerful, and it will get your jobs done very, very quickly. And changing views from the feature group view to the group feature view in the feature navigator. That's important to me to let you understand, because it's very good to be able to see the feature groups so that when you go to the geometry view of the Operation Navigator, you understand what those top level feature groups are and not seeing the features themselves. So our next session is going to be token-based licensing. That will be on September 5th, Thursday, September 5th. And the title of it will be Token-Based Licensing. Your presenter will be Paul Brown. He's a Senior Marketing Director, NX Product Engineering Software for Siemens PLM. And if you guys have any questions, here is Andrea's email, and you can submit those questions and she will forward them to me and I will get back to you immediately.
Yep, and we also have a quick little survey that'll pop up as soon as we close this session. Let us know how we did today, and let us know if you have any suggestions for future sessions. And you can also, add any questions in there. We'll be happy to follow up with you.
Great, Andrea, thank you. Mm-hmm. And if you're ever ready to take it to the next level, Us at Saratech, we offer many, many different services. We have engineering services to address all your demands for advanced engineering capabilities, whether that's from FEMAP all the way down through manufacturing. We have a great additive manufacturing team. We support Markforged, HP, Big Rep, Union Tech. And with that, I thank you for attending. And here's some quick links for different things that we offer for Saratech, our Facebook, LinkedIn, YouTube, and saratech.com.
Thank you, Mark. Great job. Yeah, make sure that you subscribe to our YouTube channel. That's where all of our videos are always posted, like the ones we've done today. We also have very short videos. You can really get sucked into those, and we hope that you find them very helpful. And with that, I think that is it. Please stick around for just about 1 minute and fill out that survey when it pops up. We hope to see you all at the next session. Have a great day.
Thank you, everybody.